Hey guys, so we are starting our quadratic equations unit, and I am not there with you, but I am going to have you guys do a video with me so I can go through the lesson that I would have taught you. And we are going to start, and this is your checklist for the unit, we're going to start on this one, number 1, the review of polynomials. So I need to catch anything that you might have forgotten when you did polynomials in your focus areas. So I'm going to go all the way to page 3, is where it starts. And let's just see what you remember. I'm going to zoom out a little bit. And make sure that you know what you're doing when it comes to just polynomials. So number 1 says, write the polynomials so that the exponents decrease from left to right. Okay, so that one's not tricky. You're looking at the exponents right here. You can see this one has an exponent of a 4. What's the exponent on this one? It's like an exponent of 1. It's like a to the first right there. And then you've got 7a to the 6th and 3a squared. So left to right, if they decrease, it would be the 6 would be the highest. So 7a to the 6th. And then we've got, what's left, the 4th. You could say plus negative 5a to the 4th, or you could just say minus 5a to the 4th, either way. And then we'd have the squared left, plus 3a squared. And then either this minus 2a to the first or plus a negative 2a to the first, either way. This is the standard form when you're getting an answer that might have more than one exponent in it. If they're all the same base but different exponents, you would normally write them in order from greatest to smallest, just to get used to that form. All right, now let's talk about this word, the degree of the polynomial. Do you guys know what that is, the degree of it? Basically, this polynomial right here has 3 terms. There's 3 things that are being added together, right? This one, really, the term is plus a negative 4rs squared. This one's negative 2r cubed s squared. This one's 5r squared st cubed. But those are the 3 terms for the polynomial. So for us to look at the degree of the polynomial, we want to look at the degree of each term first. So let's look at these as separate terms. Can you guys tell me this one, what is the degree of just that term? And to get that, we look at the degree of all of the exponents in there. This has an exponent of a 3 and this has an exponent of a 2, and we add them together. So the degree of this term is 3 plus 2, it is 5. This term is degree 5. Let's do that for this term. This term here that's being added up is a degree, let's see, there's an r squared, so that's 2. There's an s and a t, they don't have exponents, so that means their exponent is just to the power of 1. So this is 2 plus 1 plus 1, which is going to be a 4th degree. We say a degree of 4, or it's a 4th degree term. And this one over here, let's see, r squared, so that's 2, s to the first is 1, and t cubed, 1, 2, 3, 4, 5, 6. So this term is degree 6. So those are the degrees of all the terms. If we're finding the degree of the whole thing, the whole polynomial, it is the highest degree of any of the terms. So which one of these is the highest one? 6. So we say that this polynomial is a 6th degree polynomial because that's the largest degree of any of the terms. So I don't know if you guys caught that when you were doing your focus areas, but that's what it means to be a degree, is you add up the exponents for each term and then see which one has the biggest degree for the whole polynomial. All right, now looking at just polynomials, polynomial means it's got more than one thing. Poly is multiple terms, essentially, in here. So we want to know, if we're looking at this, classify it. We know it's a polynomial, but is it a monomial? Is it a binomial? Is it a trinomial? Which one would it be? There's 3 different terms. If it were one term, if it was just this, it would be monomial. So a polynomial, even though that's not more than one, a monomial could be considered within that category. Okay. All right, binomial, that's better polynomial. There's at least 2 right there. Binomial would be 2 terms, trinomial is 3. So this one is a trinomial. And what's the degree of this one? Remember, we look at the degree of each of the terms. Which one has the largest degree? This one's a 3rd degree term, so this is a 3rd degree polynomial right there. All right, let's see if we remember how to deal with adding, subtracting, multiplying, dividing with polynomials. This one says find the sum or difference. So if we're doing this minus this plus this plus this, If we're adding them together, there's nothing we need to worry about with like a distributive property out front. It would just be a 1 in front here. Do we really even need these parentheses? We really don't. It's just going to be this stuff plus this stuff. So as long as we're careful with this negative right here, this is really not a 4. It's really a negative 4. It's plus a negative right there. So now we can just add things together. The way that we can add them together is if they have like terms, the exact same variable with the same degree. So a cubes can add on with other a cubes. 4a cubed plus 6a cubed is 10a cubed. And then the a squareds can combine, they can add together. Negative 4a squared plus 5a squared would be 1a squared. And you could just say a squared. You don't have to put the 1 in front of it. But that would just be adding terms. You're just combining the like terms that are there. No trick to that one. On 5, we have to be careful. Let me move it over so we can see it better. Because of this minus right here, it's like minus 1. Really, that negative needs to be distributed across all of these first before we can add it up. So I think about this as plus a negative. That's one thing you guys are missing in the 7-8 curriculum that we're doing is I really encourage people to change subtraction to adding the opposite, or at least think about it as that way in your mind so that you don't make silly mistakes with negatives. So this is like a negative 1 being multiplied by everything here. There's nothing we need to do to multiply on the first one. That all stays the same for now. But now this becomes that negative being multiplied through either plus a negative 5x squared or minus 5x squared. This one already was a negative, so a negative times a negative becomes a positive 5x. This one was a positive, so a negative times a positive becomes a negative 6 or a minus 6 on there. And now the parentheses are gone because we didn't need them here and we did the distributive property to get rid of them there. Now you guys can just combine the like terms. So what's like here? X squared and x squared. Those can go together and you get negative 2x squared. Here's some x's. 2x and 5x gives me 7x. And then, do you guys remember what these numbers are called that aren't with variables? They're by themselves. They are constants. The constants can be combined. And remember, that's like a negative 2. It's not a 2. It'd be like plus a negative. So negative 2 plus negative 6 would be negative 8. So there's our new simplified polynomial right there for that subtraction problem that we had. All right. Now it says find the product. So product is the answer to a multiplication problem. And we'll see if there's any shortcuts that we see along the way. It says for this one, if we're going to find the product, this is like a distributive property. You're just going to multiply this all the way through. If there's something on the outside, got to distribute it all the way through. So we're just doing 3 multiplication problems here to see what we get and see if we can combine anything at the end. Negative 4n times 2n squared, n cubed. So you can multiply the numbers, no big deal. Negative 4 times 2 is negative 8. And then what do you get when you do n times n cubed? Can you do that? Can you do n times n cubed? Yeah, remember our exponent rules? This would be like n to the first. So if you got n times n cubed, it's n to the 4th. It'd be like n times n times n times n. There's 4 of them. So you add the exponents when it's the same base and you're multiplying. N to the 4th. Minus, and then this is a negative times a positive if we think about it that way. Or we could change this to plus a negative. That actually makes it a lot easier for us because this becomes plus, and what's a negative times a negative? A positive 12. And what's n times n? N squared. And then negative 4n times 2 would be negative 8n. So now, is there anything that we can combine? No, there's no like terms. This is n to the 4th, n squared, n. So there we go. We multiplied it together. We got the product. We're done with that one. This guy, x minus 3 squared, really just means x minus 3 times x minus 3. Okay, so you guys have practiced before doing the FOIL is kind of the way they help you remember it. But basically, it's just a double distributive property. We have to multiply everything in this one by everything in this one. So I'm going to multiply these two together. And then I think of first outside, and then inside, and then last. It does not matter what order you do it, as long as you multiply everything by everything else. So x times x, x squared. X times negative 3, plus negative 3x. Negative 3 times x is another negative 3x. And then negative 3 times a negative 3 becomes a positive 9 when we're doing this. All right, so here, what happens in the middle? Negative 3x plus negative 3x, we can totally combine those, and we get x squared plus negative 6x plus 9. If you do enough of these, you start to see shortcuts for this one that you can just double this number here, and that's what goes with the x, and you can square this number here, and that's what goes at the end, because isn't that what we're doing? We have two of these, negative 3x's, and we're doing negative 3 times negative 3 to get the 9. So that would be like this pattern shortcut that you could see when you're multiplying two of the same binomial together, when you're squaring the same binomial. All right, so let's do some more product ones down here at the bottom. This one isn't the same binomial. This one's really, really similar, but this one is a minus and this one is a plus. So let's see what happens to this one, see if we see any patterns there. This just says number 8 in front of it that got cut off for us, so there's nothing that we were missing. If I FOIL this first, outside, inside, last, or at least do that full distributive property, everything gets multiplied together. 2w times 2w. 2 times 2 is 4. Sometimes people forget that, and they leave a 2. W times w is w squared. 2w times 3 would be plus 6w. And then negative 3 times 2 is going to be plus a negative 6w. And on the outside, negative 3 times 3 would be negative 9. What happens to 6w minus 6w, or plus a negative 6w? That's just 0. All we end up with is 4w squared plus negative 9. So for this one, when you are multiplying and it is the same number in the front and the same number in the back, and one is plus and one is minus, look at what happened at the end. We just squared the first, 2w times 2w, 4w squared. We squared the second, 3 times 3 is 9, and you go with a negative right there. You don't even have any w's left because they're always going to cancel each other. I don't know if you've picked up on anything like that before when you were practicing multiplying your binomials. All right, you could always just FOIL it like we did if you didn't remember that shortcut, essentially. All right, and then last one over here for product. This one is just going to be multiply everything. Let's see what you got. Go ahead, pause the video. You guys get an answer to this, and then unpause it when you're ready to check. Okay, I'm going to do this quickly because you're just checking it. 4z squared minus 8z plus 9z minus 18. My z's, I tend to put little lines through them so they don't look like 2's like that. That's like a math z. And then becomes plus 1z minus 18. Or plus a negative 18 at the end. And that would be our product when we multiply those. Okay, doing okay so far? Let's look at the next page and see what else we've got. Oh, I do have a couple more products for you, and then we'll do some factoring. Okay, I'm going to have you guys try both 10 and 11. And I am going to, 10 shouldn't be an issue for you. In fact, you might be able to see a pattern that you can use for that. Number 11 might be a little bit trickier. So here's what I'm going to do. Try both of them. I'm going to pause the video, and when it comes back on, when you start it again, I'm just going to have the answer right here for you, and then I will walk you through this one. But pause it, try 10 and 11, and then come on back. Okay, if you're back, you're checking your work for number 10. This one, when you multiply it all out, 4s squared plus 10s plus 10s plus 25, which becomes 4s squared plus 20s plus 25. If you remembered this squaring the same binomial, square this one. You square the end, and you multiply these guys together times 2 is what it gets in the middle there. Okay, but there is our final product for that. This guy, this is an extension of doing like a FOIL right here. Distributive property, you have to multiply everything together by everything else. Same thing here. We're going to take everything in this one and multiply it by everything in this one. So it's up to you how you want to do it. I'm going to do d squared times d and then d squared times 1, and I'll be done with my d squared. Then I'll do 3d times d and 3d times 1 and be done with my 3d. Then I'll do my 2 times everything. So I'm going to take this step by step. D squared times D is D cubed. D squared times 1 is just D squared. Done with my D's. Going on to my 3Ds. 3D times D is 3D squared. 3D times 1 is 3D. Now to my 2. 2 times D is 2D. 2 times 1 is 2. Those are all now my terms that I get when I did that multiplication for my new product. And now I see what I can combine. I see a D squared and a D squared. I see D, and I think those are all the things I can combine. So the D cubed was by itself. It's only one of them. D squared and 3D squared, 4D squared. The D's would be 5D's plus 2. And that is our final product for that guy. So it doesn't just have to be binomials that you can FOIL, essentially. You still do it with anything bigger. We could do 2 trinomials, and you'd be multiplying this by 3 things over there, and you could make that happen. So now you've got your rules for multiplication. Do you guys know how to factor? Factor out the greatest common factor? So we're looking at, what do these 2 terms have in common? What's everything they have in common to try and factor it out? All right, between 21 and 35, those whole numbers, what do they have that's the greatest common factor? You can divide them both by 7 is the greatest common factor for those, because 7 times 3 and 7 times 5. Okay, are there any variables that they have in common? They both have an A. That's a common factor. Do they both have a B? Yeah, this one has a B, and this one has B squared, which is really a B times B. So is there a B in there that we could factor out? Yeah. Are there B squareds for both of them? No, but they each do have at least one B in there. So if we pulled those out, if we divided it by that, what would be left in our original polynomial right here? 27 divided by 7 would be 3. And what's AB squared divided by AB? A divided by A would be 1. It would go away. B squared divided by B, if we're taking out the B, we'd be left with a B. And here's how you can check it. Maybe it makes more sense to work backwards. This times this should give us what's there. 7 times 3 is 21. A times nothing is just A. B times B is B squared. So it gives us that backwards way to check it. What about this? Let's think about it that way. This times what would give us 35AB? 7 times 5, and then AB is already there. We don't want to multiply it by anything. So literally it's just 5. That's the greatest common factor. That's what's left after you take out the greatest common factor. So if I did the distributive property and did this times this and this times this, I end up with what I had at the beginning. So that's what's called factoring. This is the greatest common factor right there now that's out in front. So you guys try this. Pause the video, go ahead and factor it, pull something out in front, and show me what's left, and then come on back to me. Okay, did you pull out 6 as a whole number as the greatest common factor? They can both be divided by 6, and they both have a G in them. That would be the greatest common factor, and let's see what's left. To get from here to here, you'd have a 6 already, you'd need an F squared, and there were G cubed, so you'd need 2 more G's. You'd need a G squared as well. Over here, you'd need 6 times 2 would be 12, but you already have a G. So 6G times 2 is 12G. So we have inside F squared G squared plus 2. So that would be our factored form for this one, if we're factoring out a greatest common factor. All right, last one on here. A flower garden we're looking at. Okay, it is 4 feet longer than its width, and we're writing an equation that describes the area as a product and as a sum for this one. This is so similar to something that we did when we were doing the quadratics and doing the area formulas before. So if we're looking at 4 feet longer than the width, here's what we know. If I was doing this, I assume that this is going to be a rectangle. I don't think it says rectangular garden, but it does say length and width. So we're going to assume that it is going to be length and width. So this is supposed to be the length of a flower garden, right? It's 4 feet longer than the width. We know the width. We don't know the length, but we know that it's 4 feet longer than the width. 4 more than W. How do we write the area of that garden? Okay, couldn't we just do length times width? But we don't know the length. We know it's 4 longer than the width. So the area equals width times width plus 4, length times width, is going to be our area. So this is writing the equation as a product. This is multiplying two things. If we wrote it as a sum, it just means do the multiplication and get a polynomial. How would we simplify this? Do the distributive property, you would get w squared plus w times 4 is just 4w. That's writing it as a sum of two different things. So that's the way we can look at the area in a couple of different ways. Okay, you guys did a great job with this one. We're going to move on to the next thing for today.